Geometric series. Now that we know about a geometric sequence, if we want to add all those terms up, so the sum of the terms, we can do that by using this rule. There are two rules, but it doesn't really matter. They're just swapping the inside brackets, these and these. And when we're summing them, we actually call it the geometric series instead of the arithmetic series. Example 24. Find the sum of the first 9 terms of the sequence. So we can see here that A equals 1/3, my first term, and we can work out the R. The R will be 1/9 divided by 1/3, which ends up being 1/9 times 3 on 1, which ends up being 1/3. And I want to find the first 9 terms, so n equals 9. So I've got my rule. S of 9 equals my R. There it is there. So my A, then my R is 1/3 to the power of n minus 1 divided by R, which is 1/3 minus 1. Now, I should do this all on our calculator. Okay, when we end up doing this, we end up getting 0.4999975. Example 25. For the geometric sequence 1, 3, 9, etc., how many terms must be added together to obtain the sum of that one? So we've got our A star, A is 1. We know our R is 3. We don't even need to look at that. And we know that S of n, so the sum of all of them, is 1093. So we've got our rule, S of n equals A, R to the n minus 1 divided by R minus 1. Our A is 1. Oh, S of n is going to be 1093, we know that. Our A is 1. R is 3 to the power of n minus 1. 3 minus 1. So 3 minus 1 is 2. So we're going to get 1093 times 2. We can use the solve if we have to on our calculator. We're going to add 1. So we're going to get 3 to the power of n equals, when we work that out, 2187. And now when we use the solve, we're going to get n equals 7. Example 26. In the 15-day Tour de Moravia, the cyclist must ride 120 kilometers on the first day, and each successive days they ride 90% of the distance of the previous day. Part A, how far do they ride in total to the nearest kilometer? Well, here my A, my initial starting is 120. They have to ride 120 kilometers in the first day. My R is 0.9, 90% of that. So we want S of n. I'll write my rule down. A, R to the n minus 1 divided by R minus 1. Some people here would use this other rule. It doesn't really matter. We want 15 days, so we want S of 15. My A is 120. My R is 0.9. We have 15 minus 1 divided by 0.9 minus 1. The reason they change those around is because I'm going to get a negative here, but it won't matter. It still should give us the same amount of 953 kilometers. That was part A. Part B, after how many days will they have ridden half that distance? So I've still got my A is 120. I still know my R equals 0.9. I better right, and half of 953 is 476.5. So writing my rule, this time I'll write the rule the other way, like I said, because the R is less than 1. You only write it the other way when R is less than 1. So I've got A, 1 minus R to the power of n divided by 1 minus R, and that will equal 476.5, 120, 1 minus 0.9 to the power of n divided by 1 minus 0.9. And we're going to need our calculator anyway. And when we do that, we're going to get n equals, well, it's approximately 4.8. So it'll be on the 5th day. Oops.